So I'll give a quick update on the Monday meeting for those of you who couldn't attend. So on Monday, we ended up discussing the references issue that we've been going over the last 2 weeks or so. I explained 3 different approaches we'd been considering, and we discussed which one would be the best, and we agreed on one of them pretty unanimously at the end of it. So today I'll go over those approaches, and I'll also explain which is the decision we made and why. And after that, I want to explain and get feedback on the next steps in terms of the KEP approval. And finally, I've got the roadmap for the development of this this project, and also in terms of next steps in terms of other features and considerations as well. So I'll get started with the approaches that we discussed. So here, what I've drawn here are the different resources that Cozy ecosystem handles. So on the left-hand side, we have the bucket and bucket class and bucket request. So when a user wants to create a bucket, they would create a bucket request and they would point it to a bucket class, which has certain parameters about how the bucket should be created. And Cozy will be able to use these 2 pieces of information to go ahead and create the bucket. When the user wants to access that bucket, they would create a bucket access request and point it to a corresponding bucket access class. And Cozy would be able to use that to provision access for that bucket and provide it back to the user. Now, this is how the different resources are interconnected with each other. In this model, which is the first model we considered, a bucket access request, the way it would it would define what bucket it wants to access for would be by referring to the bucket request. But this approach had a bunch of issues that we addressed. The first one being, so I'm going to go to the next slide. Okay, this is the same diagram, but with bucket access requests from multiple namespaces wanting access to the same bucket. So what happens in such an approach when multiple namespaces want to utilize the same bucket? The number of references from bucket request to a bucket becomes many to one. And bucket request is a namespace resource, whereas bucket is a clustered resource. And we've seen before in the PVPVC workflow that managing many-to-one references is very hard. The second issue we saw with this approach was when we're trying to port this workload from, say, one cluster to another. The way the buckets are generated, let's say in the first cluster, I create a bucket request, I'm pointing to a bucket class, and Cozy goes ahead and creates a bucket. The name of the bucket will be auto-generated. So it's likely going to be a UUID. That bucket request will point to that UUID. Now, if I were to take that bucket request and move it to a different cluster, the name of the bucket is not going to be the same. So what ends up happening is we end up with portability issues. Let me think this through. I will get back to the portability issue in a second. I want to actually also go, this actually plays into the next approach also, but this approach fundamentally has the many-to-one problem. Let me quickly go to the next one and we'll address this also. Okay. Yeah. So one of the things we discussed was rather than having the bucket access request point to the bucket request, why not point to the bucket directly from the bucket access class? The idea being the bucket access class would be created by the admin, And if the bucket name actually ends up being new, that's okay, because the admin would be the one that has to do that manual step of finding the right bucket name and putting in the bucket access class. So the assumption is the admin burden is acceptable in this case, rather than the burden on the user to get this. And also the other assumption we made was any user resources, such as the bucket request or bucket access request, should be portable out of the box. So in order to facilitate that, we came up with this approach of using bucket or pointing to the bucket directly from the bucket access class. So the problem with this issue, with this model, was if we create a new bucket, if a user creates a new bucket by creating a bucket request, and if that user wants to use that bucket, the admin has to go ahead and create a bucket access class for that bucket before the user can use it. So there's an admin step involved. The second issue is, for every type of access to that bucket, a new bucket access class would be required for each bucket. So we end up with two problems here. So we also couldn't quite go with this approach. Finally, what we agreed on was this approach where a bucket request would point to just one bucket, and the reference to a bucket will always be a single reference. So a bucket request to bucket is always a one-to-one relationship, which is much easier to manage. And for cases where the bucket needs to be shared across namespaces, the plan was to create a copy over the bucket for the next namespace, for the namespace that wants it, and have a bucket request, have the user create a bucket request pointing to that bucket, and then utilize the bucket by pointing the bucket access request to the bucket request. Now, yeah, so this is where we ended up. Now, so first thing I want to ask is, does anyone have any questions about this?
So just to clarify, this is a one-to-one mapping between bucket request and bucket. Mm-hmm. And you can have multiple bucket access requests pointing to this bucket request in the same namespace.
Right.
And the only place you have duplication is across namespaces, which is an existing issue with PVPVC.
Right. Okay. Right. So that's the model.
And then for the brownfield where you already have the bucket, the cluster admin would create the bucket object with some known name.
Yeah.
And the bucket request would bind just the way PVPVC does for existing volumes.
Right.
Okay.
An admin or some controller acting on the admin's behalf.
Got it.
But we don't have to define that yet.
Mm-hmm. Yeah.
Yeah, basically, we define like a brownfield as static provisioning case, right? Where in advance, we provision the bucket, refer to bucket request, and then user can just deploy a bucket request and it will automatically be bound to the bucket. Is that right?
Sorry, could you repeat that, please?
Yeah, I'm trying to see how we model the brownfield.
Mm-hmm.
Is it like similar to how static binding of PVPVC works, or it's a bit different here?
Yeah, it is similar to the static binding of PVPVC.
Okay.
Yeah.
Okay.
Yeah. Yeah, it's not, we don't have a mechanism to do something like the dynamic binding of PVPVC. The dynamic binding in PVPVC uses access modes, I believe, and capacity, I think. So combination of those two. Yeah, we don't have that here. Yeah, this is the approach we all liked, and this was the last thing that we discussed, and I think this was the last item on the list of things we needed before we can go forward with the KEP. So what we ended up doing after that was we went ahead, updated the KEP to have the latest design, this one, and we've made sure that it follows all the standards that it needs to follow, and we've updated it, and I think we sent out a message yesterday to ask for everyone's review. So please take some time to review it and leave your comments on the CAP. We would appreciate it. Yeah, that's where we are right now. So what I'm going to do now is, one second, let me actually go to the roadmap.
Actually, sorry, I have one more question. Can you please go back?
Yeah.
The bucket to bucket access in the left bottom corner, is it bucket pointing directly to bucket access? Is that right? And it's one to many, right? I'm just trying to understand.
Oh, so actually, so let me so Jeff, did we remove the bindings from bucket to bucket access, or did we say we still need it?
The field that had binding in its name is removed. It's instead the CAP right now, the API spec for the bucket instance and the bucket access instance shows a two-way reference. The bucket points to the BA and vice versa. So there's an implicit binding in that you see the reference.
Wait, so we have bucket request pointing to bucket and bucket pointing to bucket request, and then bucket also pointing to bucket access and vice versa?
Yes.
Wait, bucket is, okay, let's go through the CAP.
You can see it in the CAP. Now, there haven't been review comments on that, but at one point in the life of the CAP, we actually had like a binding array in there when we had the many to one, and instead it's just a one-to-one reference.
From bucket to bucket access? That doesn't make sense.
You can have multiple accesses.
Right.
Bucket, so it's a fan-in, it's a many to one, but you can't have the bucket point back to the accesses because that would require maintaining a list in the object, which is always a bad idea.
Yeah, we removed it. We don't need it. So that's why I was confirming with Jeff. So this diagram may not be there. Sorry?
The access path and provision paths are separate, right?
Yeah. So let me ask you this. So last we spoke, we had removed that field from the CAP, the bindings field. And there was no explicit, we couldn't actually go from bucket to bucket access. This diagram can be updated. So let me open that up. Bucket. Yeah, so there used to be a bucket access binding here. We don't have that. So let me see if there is some reference to bucket access from here. So
number 9.
What? Okay. So I don't remember when this was introduced, Jeff. So can you help me understand this?
Yeah, can you help me understand what the
concern is?
So a bucket access, you're saying doesn't reference a bucket?
Yeah, no, the other way. A bucket doesn't reference the bucket access. And also bucket access need not have a direct pointer to the bucket.
The BAR has reference to BR, right? That's all.
Yeah. I think this was, as far as I can tell, I think this was a
minor change that we need to make there. So.
No, I'm saying this was like introduced without. Yeah, I think this should just be removed. I don't see any reason to have this.
I agree.
Okay.
+1.
+1, okay.
That's easy to do, of course.
Yeah. Yeah, that shouldn't be there. Oh, and I can update the diagram. This also. So yeah, that was a good question. Whoever asked that.
And just to be clear, does bucket access point back to bucket directly?
No.
Okay, good.
Yeah. Let's also verify that. Great, it does. So we'll remove that.
Well, hold on. Why is this bad? A one-way binding so that you can
We
know
don't
which
need it.
bucket the access refers to.
I would try to minimize the number of pointers, because the more pointers you have back and forth, the more likely state is going to end up skewing and pointing to
But
the
yeah,
wrong things. So do we
yeah,
need it?
Yeah, I get that.
you will never create a bucket access request without knowing what bucket you're pointing to, and you'll never change it. So you know it once at creation time, and you'll set it. And then if you only want to look at the non-namespaced objects, it's nice to know which access requests or which accesses are related to which buckets.
So it's really
that.
just for, yeah, it's for the admin to know where it's pointing to, I guess.
No, we also need it for the finalizer, I think, right? So we said that the bucket will wait for bucket access to drop.
No, so
But you can implement finalizers without having the explicit pointer.
Yeah.
I think. Well, can you?
Well,
Maybe you can't. I don't know. I feel like this one-way pointer here has value and won't cause any problems. That's my opinion.
Yeah.
Yeah, I can buy the argument that a bucket access request is simply requesting access to a specific bucket, but in order for the bucket needs to confirm that that has happened, and it can use an internal pointer to do that. And that way, even if the bucket access request goes away in the future because the user deletes it, the bucket has a way to be able to dereference what the bucket is that it's associated with. I don't know if that's a real concern, but especially now that we have finalizers.
Yeah, another question.
Go ahead.
Well, you need to know which finalizers to delete when you delete a bucket access, right? When you delete the non-namespace bucket access, if it's the last one that refers to a bucket, then you can remove whatever finalizer is being used by the access requests or by the accesses. And in particular, I'm thinking a bucket access corresponds in the real world to like a credential, and credentials are kind of meaningless if the bucket is gone. So it's important to know which bucket the credential is related to, so that if the bucket is gone, you know that it's a worthless credential.
I guess if we didn't have this, that would mean the controller would have to kind of go back up the chain,
right,
and come back down, right? It would need to go look at the bucket access request, then look at the bucket request, and then look at the bucket.
Yeah.
And I guess this would save that work.
Well, I think the one value is definitely the admin can just look at it and say which bucket it points to. That part.
Yeah, but I have another use case. If I do we plan to have static provisioning of bucket access as well, so that I pre-create as an admin bucket access?
So yeah, so we thought about it. So the way we look at it, if the admin wants to provide access, static set of credentials, they would just have to create the secret with the credentials, and in the bucket access request, point to that secret, and a static bucket access would be created by Cozy with no provisioner set.
And so I guess that's the case that I'm curious about, because if the user foo-bars it and points to the wrong bucket in the bucket access object, and the bucket access request points to a different bucket, how are we going to handle that? Does that mean we need to do checks everywhere to make sure that both of those align, which means we have to dereference them all the time? Or do we just say, well, hopefully these are both pointing to the same thing and just use them wherever we need them?
So the secrets are opaque to us. So if the admin creates a bucket request, assuming the secret is for, say, bucket one, but actually, and the bucket request, however, points to bucket one, but then the secret is not for bucket one, Cozy can't verify that. It's simply just going to hope that they got it right and work that way. It's going to fail when it's mounted to the pod, and they would see that access denied, and the admin can intervene at that point.
I guess my concern is we're providing two ways to be able to point to a bucket. And if those two ways, for whatever reason, because user messed up, point to two different sets of buckets, what do we do? Do we say, well, that's going to happen and, bad things happen? Or are we going to proactively try to detect that and give the user an error?
Is the scenario you're describing where someone mutates the resource and changes the reference?
It's not necessarily a mutation, it's a creation, right? If you're statically creating the bucket access request and bucket access, you could say, make a mistake and point to a bucket in your bucket access that is different from the bucket that your bucket access request is going to point to, because bucket access request points to bucket request, and bucket request could point to
do we really
bucket.
need to support static provisioning of bucket accesses?
No, we don't have any.
I'm uncomfortable with that in general because it's a security thing. It feels,
I mean, how do we prevent that though, right?
Well, you mean, okay, so an admin makes a BA on their own, because there's a workflow where they need to do that right now.
So quick thing, I think I actually, now that Saad brought up this point, having bucket instance name pointed to from two different sources of truth can lead to this inconsistency.
Well, I wanted to ask if the objects bind in a certain order that's reliable, we could just have a check during the final binding where if it doesn't match the other three, you could fail the last one until you fix it.
But
isn't
we cannot
that just the
guarantee
case?
any transaction, right? So it's like it's still possible that it will be inconsistent.
But isn't this just a case of being the user CRs like BAR and BR are just a representative of a request, and like the system would reject it if it doesn't make sense, but it's not. It's not that cozy.
My hope would be that one of the bindings would fail if the non-namespaced object mapping between the access and the bucket and the namespaced mapping between the access request and the bucket request were not the same. One of the bindings should fail to happen because of that, and then you have a broken object that you have to clean up and try again. Like, I think you could prevent getting into this situation with some admission controller, or the bind controller could do the needful verification before binding.
Yeah, I think it has to do the verification for sure. But what's the strong reason to have a bucket instance name here, though? It seems like we can other than the admin could see it.
I think you don't want the user to take off a reference, which is so crucial for the model that we're representing.
Yeah, the only kind of unusual thing here is usually bindings are, at least in my kind of experience, is bi-directional, right? So we usually have reference from one object to another and backwards, right? And here we have only like one.
We have two bidirectional bindings and two unidirectional bindings, and you could make sure that one of the bidirectional bindings failed to happen if the unidirectional bindings didn't agree with each other.
Yeah, we could do that, and then somehow float up a meaningful error message so people can go and fix it. Someone else was saying something. No. Okay, so what's the resolution on this? Do we want to have this field, or do we not want to have this field?
I say yes.
Me too. I think, from my perspective, I think without having the cozy perspective of the reference and just relying on the user objects just doesn't feel right. I mean, if we do the binding, we probably want to represent that in the cozy structures, administrative structures.
I think that's fine with me. If we're going to have it, though, let's call it out in the spec how we're going to make sure that we don't prevent inconsistencies. I think we're going to have to do more work to do that. I do agree with Ben that if you prevent binding and you do your validation during binding, that could be a potential way to prevent it. but I'm not entirely certain, given what Alexi said about this is a transactionless system. I'm not sure we can guarantee that we're going to get it right in all cases.
So it's the case we're trying to account for here where the BA points to a bucket instance that's different than what the BAR through BR is pointing to. So the BR points to a bucket instance and the BA is, and the BA was created because of a BAR and the BAR references the BR. So that's our linkage. And what you're saying, Saad, is that if somehow that gets broken or corrupted, that they could be, the BA could be pointing to a different bucket instance than the BR is pointing to.
Right.
Yeah.
Yeah. So in a dynamic case, the non-namespaced objects will only be created as a result of the namespaced objects, and so you can just copy the binding correctly. But in the pre-provision case, where for some reason someone statically created a BA and pointed it at a bucket, and then the user came along and created corresponding bucket requests and bucket access requests referring to those two objects, but to the wrong bucket, then one of those bindings should fail. Probably the second one.
Yeah. So the trigger on this problem case is a manually created BA, right?
And then a user trying to import them, but using the wrong bucket.
Right. Right. Okay.
Is it okay to say there is no manual or static provisioning of BAs? Just a question.
Well, like Saad said, how do you prevent it?
But you can't prevent that. I mean, that's right, Sid. We discussed there would be no workflow where we need a manual BA. Brownfield doesn't do it. But nonetheless, what do you do if an admin does create a BA?
Yeah, I guess the question I have is, okay, if the admin does create it, I mean, there is controller logic that's eventually going to surface secrets, potentially, assuming it's in that path, into the container. Does that controller logic happen on a manually provisioned BA?
Yeah.
In other words, I'm not clear that would actually work unless you build that path in. Right? You've got to basically now put it into binding instead of into sort of the creation of the BA. So
yeah, I see what you mean. So that's why we had this concept of BARs are the only things that would be created, and if the admin wanted to provide a static access credential, they would just point to the secret from here. And that way it follows the COSI life cycle of BA being created by COSI using whatever is provided.
But
now,
from the same reasons for buckets, it made sense to have that managed as a the cluster wide CR, and let the administrator provision that brownfield cases using that object. Do you think it's still the right decision to have that like created using secrets and all, and instead of a BA?
The thing with it introduces a whole set of problems, as we were seeing right now, but there is no way to prevent it, like we're saying.
So, but like Andrew suggested, I mean, are we going to plug it in such a way that the rest of the flow would follow from the existence of that BA by the admin?
So let's say someone goes ahead and creates a BA, and in the pod workflow they would have to create a BAR that points to this BA, and we'd have to create the BAR, or we'd have to model this such that if there is a bucket access name already set, then we use what's created by the admin. That would work.
It's right, just like buckets, right? It's just like the brownfield bucket.
How do you know? What are you triggering? because, all right, so there's got to be a binding, I guess, right? So you have a one direction binding at provision time, and then that goes into a dual binding. So it's still one-to-one, right? Bucket access request to bucket access. So, so that means, so you pre-provision a bucket access. What does it have? Does it have a back reference to a bucket?
Yeah. That's the assumption, right? Yeah. This is why we were asking if we need that.
The access request gets created, doesn't actually itself have to provide a reference to a bucket access, because then you do the same kind of binding logic you do for volumes. You just basically say, is there a bucket access already out there that works for me? If there is, you don't actually do any provisioning of the bucket access. But I guess there is always this notion that post-provisioning of a bucket access, you then have to take additional steps, possibly, depending on the type of bucket access, to write credentials into the mounted volume. And so I guess my point is you would have to distinguish between a bound and an unbound, because if it's bound, we're not going to do anything. We assume the credentials are already there. So unbound, I guess it would be is that you have both a provisioning and a binding step, right? And you can, I guess, if you do it the way snapshots are, you actually provision the resource and bind it before you fill in the details. And in this case, if the details are already filled in, then you kind of, it's just a different flow, I guess, in the binding logic, where you go, well, it's already here, I don't need to provision it, but then I need to bubble the actual credentials down into the volume.
And I think I don't understand like the bubbling to the volume part. Could you please elaborate that? Because
so if we're assuming it's not the workload identity class here, assuming it is the I have a key that I need to communicate to the application, right? And remember, once upon a time, we talked about back in the day that was going to be done through a secret. We decided no, we're going to use ephemeral volumes, and we're going to do basically a custom volume, and we're going to write that secret data, not as a secret, but in well-known location in that volume. So there is a step that has to make that happen that is part of the overall, well, originally it was part of the overall provisioning of the bucket access. Now we have to be able to have a place for that also when you statically provision the bucket access. That's
I thought this step, like bubbling up to the volume, actually happens not during a BAR provisioning. It happens when we actually attach BAR to a pod.
Yeah. We don't pre-create a PV and have it ready.
Right. That's what I understood as well.
Yeah.
So in that case, two paths, they are.
That means that you have to bind it before it can be attached to the pod.
That's correct. Yes.
Yeah, yes. And that works because then there's a separate trigger. No matter how it gets bound, you handle that independently, and then it attacks time. Okay, it works.
Yeah. So coming back to this question, yes, there is a problem if the static provisioning of bucket access, where we'll have to deal with the bindings all the way from bucket access request, bucket request to the bucket. So we can choose either of the two ways. Either have the bucket instance name and deal with the binding logic, or don't have it and use the bucket access request to the bucket request as the source of truth. In terms of implementation, I think that would be easier. Are we losing anything going that way? Not having.
Well, when you say source of truth, I mean, I assume we're still saying if you've got inconsistencies, we failed.
Exactly. That's what I mean.
Right. So that means you got to basically dereference everything and evaluate it all. But you can evaluate it at binding time, which is a one-time event, at least. And then I guess maybe Alexa's point is that there are race conditions in there because resources can change after you read them.
Yeah.
So I think we cannot like guarantee like 100% consistency. But
then you could do another check at BAR attach time, right? And which would be a read-only check at that point. You could just evaluate that. But you could still change these things after the fact too, right? So I don't know. It might be good enough to just do it at binding time.
Yeah, I think binding time is the solution actually. Right before binding, you get all the resources and then check if the references, the bindings make sense.
Yeah, and after binding, it's if the admin is going to mutate it, it's out of our hands.
Yeah.
Yeah, implementing that binding logic is going to be fairly complicated. It may be worth writing a design doc on what that's going to look like, just based on how complicated the PV-PVC binding logic was.
Right.
So,
I'm afraid like maybe there is nothing. Maybe there won't be any security concerns, but we potentially may have situation when bucket access points to one bucket and bucket request points to another bucket in the end. Right. And I'm not sure like if it doesn't create any security kind of holes there.
That would either be the fault of the admin trying to set up a static binding and he did it wrong, or a bug in the provisioning controller.
No, but bucket request itself is under user's control, right? So they can actually change.
No, the bucket request.
The only thing the user can do is they can ask for one to be created, in which case it doesn't already exist and it's up to the controller to do what they asked or throw an error. Or they can try to bind one that the admin created for them, and if they don't ask for what the admin actually created, it just won't bind and they'll still get an error.
Yeah.
Okay.
Yeah, so right before putting it into the pod, we should do a check where we check if all the bindings are consistent. If not, we don't put it into the pod. So that way we can always ensure that if there are any inconsistencies, then they don't get the credentials at all.
So you get some code that you can run when this volume is getting provisioned.
So yeah, there's always, so the CSI driver, is your question that can we do this logic right before provisioning the volume or right before mounting the volume?
I mean, it runs in kubelet itself?
In the kubelet in the long run, yes. Yes, right now in the CSI driver.
But as part of the kubelet flow, right? The kubelet is
yeah. Yeah, that way we can even probably just assume that the bindings are right, and all the way until it's actually provisioned to the pod, we don't even have to check.
It sounds pretty secure to me, also because we can enhance the security checks and make sure we even reject an access. So.
Yeah. And then if it mutates after that, it doesn't matter because it's already been put into a volume. So whatever is using it will get to use it, but anyone else trying to use it in the future will not be able to use it. So I think we should just do the bindings check right before the volume is mounted into the pod, and that solves these problems, all of them. And we can continue having the bucket instance name here. Yeah, I think that's what we'll do. Any other thoughts on that?
Is there any way technically to pull off this CSI volume if we want to reject access, for example, and cause the pod that used it to restart? Or
so are you saying revoking credentials? Is that your question? Yeah, it's possible. In order to revoke the credentials, you just follow the normal volume workflow so I'm thinking about how this will be done. So the kubelet has a way to unstage a volume and unpublish it. Generally, there's a way to do it. I don't know the exact answer right now. I guess I don't know if in case of ephemeral volume you have a PV that's created. If it is, then we can remove the PV, and that would trigger the unpublished volume to be called, and
why do we want to unpublish anything? I'm trying to understand, like, why we're
so the question is, how do I take the how do I revoke whatever credential was given to a pod? And let's say after
why do we want to revoke it? Like, what's the use case? Like, why do we want to revoke? When do we
revoke credentials?
Yeah, so we don't want to
when once the use case, why do we
revoking credentials? It's a typical security practice.
Yeah.
Like, but why it happens? Like, what happens so we want to revoke it?
So
I'm trying to understand it from flow.
Tenants. Let's say, oh, someone's talking.
Well, what if you discovered that they were compromised? And we see this in stuff too that comes up where access to data needs to be revoked because you've discovered a security problem.
Okay, so you mean like we delete, like from admin point, we delete bucket access or bucket access request, and now we want to propagate the deletion into a running pod. Is that the case?
Right.
Yeah, I think the question is, how do we revoke, right? So what would be a good process for revoking? Maybe this is a good process, just deleting.
Yeah, deleting the BA. Yeah, that should be the trigger. Yes.
But it doesn't work. If you delete the BA, it doesn't change the running pod. The running pod has consumed a mounted secret and has its tokens, and they're now variables inside this binary, and you're not revoking anything unless you do it at the back end.
Yeah,
you need to do two things, right? You need to both invalidate the credentials on the service side, and then you need to make it so that if the pod restarts, it won't successfully remount.
Yeah,
that's exactly right.
And it would be good practice to kill the pod, I think.
I don't think we can.
It's probably no. Well, I mean, as if you discover that something is wrong as an admin, you know, and you see that a pod is using you go kill the pod.
Yeah.
The admin does. No, in our control.
Right.
Yeah.
Well, I think what we can probably do is just delete bucket access request or bucket access, which deletes underlying credentials from the cloud provider, right? So this way pod doesn't have any access anymore, like pod itself. So it will probably fail fast, or it will try to recover for any reason, but it's not.
Will a pod that is using an access request sort of prevent deletion with a finalizer, so that even if you delete the bucket access request, it hangs around as long as there's a pod using it?
No, I mean, that's up to us.
I think I think it's up to us. I agree.
But I mean, there are a lot of reasons you would want that finalizer, so that you don't accidentally delete a bucket access request on a pod that is using it. Because
so we want to distinguish between accidental and intentional.
Well,
no.
I think accidental can be used.
Just let's say you delete them at the same time. You delete both the pod and the bucket access request because you're done. You want to make sure that they actually get torn down in the right order.
Yeah, I completely agree with Ben here, because this is a common use case where people delete an entire namespace, and the order of deletion of objects in the namespace is not guaranteed.
Yeah, so
right. I don't quite understand what the concern is about order of deletion.
I think the pod needs to have a finalizer on the bucket access request just for correct deletion behavior, but you still need a way to say, I want to delete this, and even before the Kubernetes objects go away, I want to revoke the credential off the back end, and then Kubernetes will clean up when it cleans up. But like, I want to sort of go around with the normal object.
You want to initiate the delete deprovisioning without actually deleting the resource. Is that what you're saying?
I think so, or else the admin must delete the pod at the same time he revokes the credential to actually affect the real revocation on the back end, which doesn't seem like, I mean, I guess I would be okay with that too, but we just said you don't like the idea of just killing the pod. And
I guess the problem is, if you delete the bucket access request before you tear down the pod, will the pod have trouble tearing or terminating and cleaning up?
We don't know yet, I'm afraid.
Is it really a problem if we delete bucket? Okay, so we don't have any retention policy on bucket access requests, right? So we say that every time we delete bucket access requests, basically we delete the credentials. Is that right?
Yeah. So the pod itself won't have a finalizer on the bucket access. So pod can be deleted without deleting the bucket access, but the bucket access should it have a finalizer on the pod is the question, such that it can only be deleted after the pod is deleted.
I say yes, because if you have a pod that has a bunch of state, and part of what it does when you kill it is it flushes its state to the bucket right at the end, but you delete them both at the same time, there's a risk that the pod loses access to the bucket and it can't flush its final state, and now you have some corrupted or incomplete data in your bucket.
But that's always the case. I mean, the application is expected to handle such failures.
No, we just fixed this problem, and with PVs and PVCs, where if you delete like a pod and a PVC at the same time, it used to be possible that we would actually delete the volume while it was still attached to the pod because of erase, and then the pod you'd have dirty data that you're trying to flush to the volume, but the volume isn't there anymore, and then the kernel gets very unhappy. So this wouldn't be a kernel level problem, it would be an application level problem, but you would still have...
You would just lose the access. You just get 401s.
Maybe we make this a option on the request or on the bucket access.
Let's say I make the option to be retained, but then now I want to revoke access. How do I do it then?
Well, no, I'm not saying retain or delete. I'm saying whether you're going to have a finalizer or not.
Is there any like finalizers in PV world? Like if PVC is attached to pod, you cannot actually delete it or something like that?
Yes. Yeah.
Yes.
That's exactly what Ben's referencing.
Oh, you call it PVC protection, right?
Yes.
Yeah, we can do the same thing here. Yeah.
But that finalizer would prevent your revocation workflow.
So yeah, we have like so I think whichever way we go, we're going to make some people unhappy.
Yeah.
Well, we can potentially differentiate between delete and bucket access request versus delete and bucket access. So if admin just comes and deletes bucket access, we can consider it as forced deletion.
Yeah.
But again, like if it's not too hacky.
It's not actually. So if the bucket access request is deleted, we wait for the pod to die. But if the bucket access is directly deleted while the bucket access request is still alive, then we know it's a forced revocation of credentials. That's a good point.
The current design of Cozy has no watches on pods, across all namespaces. So we don't know
that here.
We only have our node adapter, the Cozy node adapter that gets called by the kubelet on startup and termination of a pod. But that's it. Otherwise, we have no connection to the pod.
Mm-hmm. Yeah, I think so. So I think that solves it.
What solves it, Sid?
So we're saying that if a bucket access request is deleted, initiated by the user, then we wait for the pod to die before the credentials are revoked. But if a bucket access is deleted while the bucket access request is still alive, then we know that admin initiated it and we want to revoke credentials.
But I just heard Jeff say we're not watching the pods to see if when they die.
Not, and our design doesn't have the node adapter that's called by the kubelet. It doesn't play a role in interfacing with the driver. But what you just said is it would. It wouldn't call it would. In other words,
they're just saying there would be a finalizer, and the question is how the finalizer would get added or removed.
Yeah.
Right.
Yeah.
And also the fact is that with the PVC and PV protection and all the work that went around that, and there's still outstanding issues with that, it was decided not to put a finalizer on the pod, right? And so if
we're still not putting a finalizer on the pod. We're putting the finalizer on the bucket access. And the question is, when do we remove that? Based on which resource is deleted first, we either remove that after the pod dies, or we remove that
right.
before it dies.
Okay. So okay, yeah. So we the design does have a finalizer on the BAR. Well, everything except for the classes. And so so yes, the node adapter, the Cozy adapter could be the piece of code that's responsible for removing finalizers. So it has the final say.
Yeah. Yeah. Does that answer the question? For everyone here. So to summarize what we talked about, a bucket instance name should be there, can be there. No, actually should be there. And we also know how we're going to check the binding, that is right before it's mounted into the pod. And for revoking access, the model we're following is if bucket access is deleted first, we revoke directly even if the pod is running. We don't even check. If the bucket access request is deleted, then it won't actually revoke the access until the pod is gone. So, any other questions? Okay, so in that case, let's do this. So we'll update the KEP with whatever we discussed today. Please review it and you know, share your thoughts, and we'll continue after that. Saad, is there anything else we should address?
No, sounds good to me.
Perfect. Okay. All right. Okay. Okay then.
We have 6 minutes. Can we go through the graduation criteria? What else needs to be done in the KEP? Or
yeah. Is that at the top or
at the bottom?
At the bottom. Okay. Graduation criteria. Okay. So I think we have an understanding of the API. We actually discussed today, if you want to add or remove fields, we want to remove the bucket access reference from the bucket object. Green field, green, brown field, brown field. Yes. Evaluate gaps, update KEP, and conduct reviews. Yeah, that we're doing today. Yeah, develop unit test cases. So is this required for KEP approval, or is this like alpha where, you know, we have working code? What's the difference between KEP and alpha?
Unit test is the development phase. That's the code itself. Yeah, but you just need to write down like what type of test, like at a high level.
Yeah, like test plan, right?
Yeah, something like that, right?
Okay, so we have that. Okay, so if it looks like we need to update the KEP and update whatever we talked about today. And you know, if everyone reads it, you know, thinks it's it looks good to them, then yeah, we should be able to move forward.
There's one thing I want to ask, because I remember initially we talked about making this like provisional, getting that KEP merged and then start doing POC. But then I think that's more like experimental work. Now, if we are trying to reach alpha, I think we need to also go through the API reviewer to alpha state. Yeah.
Someone was saying something. Please go ahead.
No, I was just going to agree.
Okay. So what's needed for alpha? Like, so if it's not provisional, I think in the top we had it written somewhere.
Right now it's still, it's probably should change it to implementable if you want to go alpha. I think provisional is more like doing a POC. You just have that provisional.
So for implementable, do we need to have working code, or what level of?
Oh, the KEP itself does not need that. It's but when the code is getting reviewed, when they review your code, then you would need to have.
Okay. Okay.
So KEP review.
Okay. So wouldn't we have to do implementable at some point anyways? Like, don't we have to do provisional first and then implementable? What I mean is, let's say we go ahead with provisional. Wouldn't we have to do the API reviews next and then change it to implementable?
Maybe that is, I think that maybe is not that critical for that. It's just like a status there, but I think I think depends on whether you want to reach alpha in this release, right?
Oh, I see.
If you want to reach 1.20, then just make sure that you do the API review.
I see.
I think that's more important than the status there.
Okay, and what's the quick question? What's the last date for like the code freeze was for 120 version?
I need to check. I don't remember.
Yeah, last I checked, the roadmap is not clear. But Shing, what phase of the release we have to go with the API review? Is it at the beginning or once?
So I see that starting, you probably know more. A lot of time I see that we go through that kind of at the very late stage. We should probably start this one early, so that because this is a very big cap. I think.
Yeah, I agree. So good thing is that we're pretty early in the cycle. There's two important dates in the cycle. One is feature freeze and the second is code freeze. Feature freeze normally comes within the first third of the cycle. So normally the cycles used to be a quarter long. So it would be at the beginning of the month, the first month, and then the end of the second month would be the code freeze. But because of COVID, we ended up removing one of the quarters and we only have 3 releases this cycle. So we have a little bit more time. I'm not sure what exactly the dates for feature freeze or code freeze are for 120. We should target an alpha for 120. And if we slip, we can slip it to 121. But I completely agree with Shing. Let's get the ball rolling on getting the API review. The process for that is going to be first, let's get consensus within the SIG and make sure we're all on the same page. We're good with the KEP. If we are, let's pull in the API reviewer folks, whether that's Jordan, Tim, or whoever, and have them take a look and make sure they sign off on it. Okay. That needs to be done before the feature freeze date for 120 if we want to get an alpha into 120. If we miss that date, then we're going to have to wait for 121.
I see. Yeah, let's aim for that date. Given the cap as it is, we can quickly update it and get it to a point where it's updated with whatever we talked about as of today.
And so for API review, they're going to want to see kind of the whole API. So you'll have to create the PRs for that.
We already got it.
Oh, excellent. So that'll include the spec as well as the Kubernetes API.
Yeah. So so we've got that. Anyways, it needs to be pushed up because we've been actively developing, but I don't think I see the latest part here. But yeah, we have the API, and how do we get in touch with the API review folks? Should we go through you or directly just contact them, or what's the process there?
Shing, do you know? I think there's a flag that you or a label that you put on the PR, and then that gets the attention of the API reviewers. Is my understanding.
Okay. Yeah.
But if you can't figure it out, we can talk offline and figure it out.
All right. Sounds good. Okay. Yeah, I think we should add that flag because I can hear some. Okay, so I think we should add that flag or the label, and we can quickly get the cap up to a point, and also the API repo up to a point where it's ready to be reviewed. So let's go ahead and do that, and I'll follow up with you, Saad, and you, Shing, and we'll go from there.
Sounds good. Thanks.
Perfect. All right, how much time do we have left? Okay, it's time up. Thank you, everyone. We won't have the Monday meeting this week, so I'll talk to you all on Thursday, next Thursday.
Thank you.
Thank you.
Everybody.